So let's try to solve this differential equation. So once again, whenever you have an equation written in the form m dx plus n dy is equal to 0, you find the partial derivatives and try to see if it's exact or not. So my, take the derivative of this expression with respect to y. So the 4x squared is a constant, so that one is 0. And here, since y is the variable, 3x is a constant and derivative of y is 1. So you just get 3x. And here, the 3x is a constant and the derivative of y squared is 2y. So 3x times 2y is 6xy. And nx. Nx will be the derivative of x squared is 2x. And the derivative of 2x squared y. So the derivative of 2x squared is 4x and the y is a constant. 4x y. And the two are not equal, therefore not exact. And now remember, when it's not exact, we check the difference quotient. So try this one, my minus nx over n. And one way to remember it is that, of course, the ones that appear in the numerator are exactly these two, the my and nx, and you don't have to think about which order. So whichever order you put them and subtract. So then whatever is subtracted, that's the one that comes in the denominator. I mean, not the derivative, but the original. So if you are subtracting nx, then the denominator will be n. And if you're subtracting my, then the denominator will be m. So here, and again, we want to see whether it's a function of this one or not. Whatever you're subtracting, see the subscript under that. And you want to see whether this thing is purely a function of x or not. There should be no y. So let's see. If you subtract the two, you get 3x plus 6xy minus 2x minus 4xy divided by n, and n was the thing that comes with the dy. So we need to simplify before making sure that what's going on. So it's x plus 2y, x plus 2xy on the top. And in the denominator, we have x squared plus 2x squared y. And now we will factor x, 1 plus 2y over x squared, 1 plus 2y. So this cancels, and that's 1 over x, which is a function of x alone. So this one works. So the integrating factor, is e power the integral of whatever you got in the quotient. So e power ln x, e and the ln canceling, just get x. So we will multiply the original equation by x to turn it into an exact equation. So when you multiply this original equation with x, you get is, let's copy it. So this is what we have. We multiply it with x. And then you multiply this equation by x. Every term gets multiplied by x, so this x squared becomes an x cube. This becomes an x squared. This also becomes an x squared. What's going on? Okay, some weird reason. Let's just write the x squared. This one will become x cube. Remember, everything is being multiplied by x, and this will also become x cube. And again, you can check whether this is now an exact equation or not by finding those partial derivatives again. And if your work is correct, it should be exact. I will just believe that my work is correct, and I will not check. And then, the solution is you integrate this one, and you can write down the solution is. So you integrate all of this m with respect to x. So the integral would be x to the 4 the integral of the 4x cube is x to the 4 plus the integral of 3x squared is x cube, and then we have the y, and then again x cube, and we have the y square. And in here you integrate only those terms that are free of x. So you drop the x cube and you drop the 2x cube y as well, because they both contain x cube. So in this case, we don't have any terms of n that are independent of x. We drop that, so there's nothing more is equal to c. So x4 plus x cube y plus x cube y squared. Is equal to c. And now there's a difference here. Remember, in the previous two problems, the choices were whether a solution was lost or not. Here they're asking whether a solution is gained or not. And the reason why this question has been changed is because of the integrating factor. So in the previous problem, the integrating factor was 1 over x squared. If you remember, in this problem, okay, I won't. Just remember that in the previous problem, the integrating factor was 1 over x squared. And anytime you have 1 over x or 1 over x squared, or 1 over x cubed, or anything like that, that can multiply with when that multiplies with the original equation, it can get rid of an x that is sitting in the numerator, and therefore it can result in loss of a solution. But here, instead of being 1 over x, the integrating factor was just x. Remember, you multiplied this equation with x. The integrating factor was x. And so when you multiply by x, then actually you can gain a solution. Or when you multiply by x cube or x square or any power of x, then you can gain a solution, because just think about it. Okay, let me show you the equation again. So look, here, uh, when I multiply by x, uh, I may introduce x is equal to 0 as a solution. I may gain an extra solution, and which I do, because if you look at that final version, um, the x is equal to 0, which does satisfy this equation if the constant is 0. So x is equal to 0 is a gained solution by multiplying the equation by x. However, x is equal to 0 was always the solution even of the original equation. So look at the original equation. The original equation already has x in every term, x, 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 x. So when you substitute x is equal to 0, this is 0, this is 0, and so 0 plus 0 is equal to 0. That's fine. So even though we seemingly gained a solution, x is equal to 0, by multiplying by x, but that solution was already there even without multiplying by the x. So we did not really gain anything. So that was already there. But imagine a situation where, let's say, for example, in this term, let's say that we did not have the x square over here. It was just x square plus 2y dy is equal to 0. So then even though this may still be 0, and here this is still 0, but you will have 0 plus 2y if this x square was missing. So 2y dy is equal to 0. So now x is equal to 0 is not a solution of the original equation. But if you multiply by x, then you do pick up that extra solution, and therefore then you will gain. But as the situation stands here x is present in every term, and x is equal to 0 is already a solution, so we don't gain anything.